Have you ever wondered how everything, the stars, the planets, even us, came to exist? Where did the universe come from? And what was there before it all began? Hi, and welcome to Stellar Studies, your window to the universe. Today, we're diving into the Big Bang Theory, the most widely accepted explanation for the origin of our universe. But what exactly was the Big Bang? What happened during those first moments? And what evidence do we have to support it? Grab your curiosity and let's travel back 13.8 billion years to discover how the universe began. The beginning of everything. To understand the Big Bang, we need to rewind time, not just years or centuries, but billions of years. About 13.8 billion years ago, there was nothing. No stars, no planets, no space, and no time. Everything we know today, every particle, every force, was compressed into something unimaginably small and incredibly dense, a singularity. This singularity wasn't just a dot. It was the birthplace of the universe, holding all the energy and potential to create everything. Imagine all the oceans of Earth squeezed into a single droplet. Now magnify that idea infinitely. The first fractions of a second. What happened immediately after the Big Bang? Scientists call this the Planck Epoch, which lasted only a fraction of a second, 10 to the negative 41st seconds to be exact. During this time, the universe went from a size smaller than an atom to larger than a galaxy in a blink. This incredible moment marked the birth of space and time. Energy flooded the universe, temperatures soared to unimaginable heights, and the laws of physics began to take shape. This rapid expansion, called inflation, happened in less than a trillionth of a second. Imagine something smaller than a speck of dust growing to encompass an entire cosmos. That's the power of the Big Bang. During inflation, the universe was so hot and dense that particles couldn't exist in their current form. Instead, there was a soup of pure energy, and the fundamental forces of nature, like gravity and electromagnetism, were unified. The birth of matter. After inflation ended, the universe was still incredibly hot and dense, billions of degrees. During this time, the energy from the Big Bang converted into particles. These particles included quarks, the building blocks of protons and neutrons, as well as electrons and photons. For the first few microseconds, quarks couldn't form stable combinations. About 3 minutes after the Big Bang, the universe had cooled enough for protons and neutrons to stick together, forming the first atomic nuclei. This process is called nucleosynthesis. This was the beginning of matter as we know it. Most of these nuclei were hydrogen and helium, with tiny traces of lithium. These light elements make up about 99% of all matter in the universe even today. But at this stage, the universe was still too hot for electrons to combine with these nuclei, so there were no neutral atoms, just a plasma of charged particles and light. The first light. After inflation, the universe was still hot and dense, a chaotic soup of particles. Around 380,000 years later, the universe cooled enough for particles to combine into atoms, allowing light to travel freely for the first time. This light, known as the cosmic microwave background, or CMB, is like a photograph of the universe as a baby. When scientists map the CMB, they see tiny temperature variations, remnants of the quantum fluctuations. These variations became the seeds for galaxies and stars to form. The CMB is more than just a pretty glow. By studying it, scientists have uncovered clues about the universe's age, composition, and even its fate. For millions of years after the CMB, the universe entered what we call the Dark Ages. There were no stars, no galaxies, just clouds of hydrogen and helium. It was a time of stillness, but gravity was hard at work. The universe takes shape. Over millions and billions of years, gravity went to work. It pulled hydrogen and helium together to form stars, the cosmic engines of creation. Inside these stars, nuclear fusion forged heavier elements like carbon, oxygen, and iron, the building blocks of planets and life. When stars died in spectacular explosions called supernovae, they scattered these elements across the cosmos, seeding the next generation of stars and planets. Eventually, some of that stardust came together to form our solar system, Earth, and well, you. Evidence for the Big Bang. Okay, so you might be wondering, how do we know the Big Bang really happened? Scientists have gathered a mountain of evidence. First is the expansion of the universe. In 1929, Edwin Hubble discovered that galaxies are moving away from us, and the farther away they are, the faster they're moving. This is direct evidence that the universe is expanding, just like the Big Bang predicts. Second is cosmic microwave background. The CMB is like a fossil of the early universe, a perfect remnant of the heat left over from the Big Bang. Its uniformity and tiny fluctuations match the predictions of the theory. Third is the abundance of light elements. The Big Bang theory accurately predicts the amounts of hydrogen, helium, and lithium observed in the universe. No other theory explains this so precisely. What came before the Big Bang? But what about before the Big Bang? That's one of the biggest unanswered questions in science. Some theories suggest there was no before, because time itself started with the Big Bang. Without time, there's no before as we understand it. It's like asking, what's north of the North Pole? Some other theories suggest that our universe could be part of a cycle of expansions and contractions, like a cosmic heartbeat. Others speculate that our universe might have emerged from a quantum fluctuation, a random blip in a field of energy. And then there's the multiverse idea. Imagine countless universes existing side by side, with ours just being one of many. It's wild to think about, but right now, what happened before the Big Bang is a question we're still trying to answer. Expanding horizons. Today, the universe continues to expand. Galaxies are moving farther apart, and scientists are still trying to understand why. Dark energy, a mysterious force, seems to be driving this accelerated expansion. By studying the expansion, we're not only looking at the past, but predicting the future of the universe. Will it expand forever? Will it slow down? Or will it collapse in a big crunch? These questions keep cosmologists up at night, inspiring exploration. So, that's the story of the Big Bang, a tiny, hot start that grew into the incredible universe we see today. From stars to galaxies to the Earth we call home, everything we see began with this amazing event. If you enjoyed this deep dive into the origins of the universe, don't forget to like, subscribe, and hit the bell icon to join the Stellar Studies community. What's your favorite cosmic mystery? Let me know in the comments below. Until next time, keep looking up and wondering, because the universe is full of stories waiting to be told. This is Stellar Studies signing off.